In this lesson, we're going to do some naming and formula writing. We're going to start by going through the naming rules. So first thing we do is we write the cation first. Remember, we want to start with good news before we start with the bad news. Okay, it's always a good idea to soften the blow. So we write the cation first, and then we write the anion. Step 2, the name of the cation never changes. So you'll see some examples here in a second, and this will make a little bit more sense. The third step is the most important. For the anion, we drop the ending and add IDE. So for example, sodium chloride. We have Na, sodium. So remember, step 2, the ending never changes. So if you look, we start with sodium, we end with sodium. So the cation never changes. For the anion, the original ending is chlorine. So we take that ending, we drop it, and we change it to IDE. So instead of sodium chlorine, it's sodium chloride. And that's how you do naming. Let's take a look at a few examples. The example says, write the formula and the name for the following ionic compound. So let's start with the name. So first of all, if you notice, we have K, which is potassium. Okay, so I'm going to go ahead and start by writing that out. So potassium. Okay, and then we have S, which is sulfur. Okay, now we don't leave it as sulfur. We want to change the ending to IDE. So when we write out our name, we're going to leave the cation the same. So it's going to be potassium. We're going to change the ending to IDE. So instead of it being sulfur, it's going to be sulfide. Okay, so we change the ending to IDE. Now, the second thing it asks us to do is to write the formula. So to do that, let's take a look at our periodic table. So let's start by finding our cation. Our cation is potassium. Potassium is in group 1A. And remember, anything with 1 to 3 valence electrons is going to lose all of them. So since it has 1 valence electron, it's going to lose that 1 valence electron. So potassium will have a charge of +1. It's got 1 more proton than electron. Okay, sulfur is right here. Sulfur is in group 6A. If you have between 5 and 7 valence electrons, you want to gain enough valence electrons so you have 8. So since it has 6, it needs to gain 2 more to get to 8. So its charge, it now has 2 more electrons, so its charge is going to be -2. Okay, so to balance this out, we're going to need 1 more potassium with a +1 charge to cancel out that sulfur with a -2 charge. So our formula will be K2S. And again, the name for this is potassium sulfide. All right, here's another example. So we've got calcium and fluorine. So if we go to our periodic table, let's do the formula first this time. So we go to our periodic table, we have calcium, which is Ca. Calcium's right here. Calcium is in group 2A. So calcium is going to lose those 2 valence electrons. It's now going to have a charge of +2. And then we had fluorine. Fluorine is right here. Fluorine is in group 7A. It needs 1 more valence electron to get to 8. So its charge will be -1. So for us to make this work, we want to add another calcium, another fluorine. So our formula will be Ca and then F2, okay? Again, the charge of fluorine is -1. The charge of calcium is +2, so we need 2 fluorines to balance that out. Okay, and then when we go to name this, we have calcium, and then we have fluorine, Okay, instead of it being fluorine, we're going to change the ending to fluoride. So it'll be calcium fluoride. Okay, so again, we change the ending to IDE. Okay, here's another example. We've got magnesium and oxygen. Let's do our formula writing first again. So if I look at the periodic table, we have magnesium. Magnesium is right here. Magnesium is in group 2A. So we'll have magnesium with the +2 charge. And then we have oxygen. Oxygen is right here. Oxygen is in group 6A. So it'll be oxygen. We need 2 more electrons to get to 8. So it'll be oxygen with a -2 charge. So to make this work, we're going to need one of each because it's already -2 + 2. So it'll be M, G, and then O. Remember, our cation goes first. And then for our naming, it's going to be magnesium. And then we have oxygen. All right, oxygen is a little tricky when it comes to naming. So you might think we just get rid of the EN at the end, but actually we're going to chop off the YGEN. So this will become magnesium. And it's going to be oxide. Okay, magnesium oxide is the proper name for this compound. Okay, so for these last two, what I'd like you to do is go ahead and pause the video and try to write out the name and the formula for the following ionic compound. We've got rubidium and nitrogen. So don't be that person that just keeps taking notes. Don't look around right now to see if anybody's watching you. Pause the video, try to work this one out on your own. I'm going to keep going through this one. Hopefully you have taken the time to go through and practice this on your own. Again, you know if you did it. Are you going to be able to live with yourself tonight? All right, let's take a look at the periodic table. We've got rubidium and nitrogen. Okay, so we've got rubidium, which is right here. It's in group 1A. So rubidium is going to have a charge of +1. It's going to lose that valence electron. And then nitrogen. Nitrogen is right here. Nitrogen is in group 5A. It needs to gain 1, 2, 3 electrons to get to 8. So it's going to have a charge of -3 when it ionizes. All right. So when we go to write out our formula, we have rubidium, and then we have nitrogen. But we need to offset the -3 with 3 rubidiums. Okay. And then our naming is going to be rubidium. That's our cation. Okay. And then our name for our anion is nitrogen. Okay. Just like oxygen, this one is a little weird. So nitrogen, we're going to hack off the OGEN. So this will become rubidium. And then it's going to be nitride. All right, let's take a look at one more here. Okay, again, I'd like you to go ahead and pause the video and try to work this one out on your own. Okay, at this point, I'm hoping you've worked through this on your own. Let's go ahead and tackle this one. So let's begin by looking at our periodic table. We have barium, which is located right here on our periodic table. There's barium. Barium is in group 2A, so barium will have a charge of +2. And then phosphorus. Phosphorus is right here. Phosphorus is in group 5A. It needs to gain 1, 2, 3 electrons. So phosphorus will have a charge of -3. All right, so this one's a little harder. Okay, well, first of all, it's a little harder because you can't see what I wrote. So let me just rewrite that down there. Okay, so we have Barium with a +2, we have phosphorus with a -3. Okay, so this one is a little tricky because I can't multiply barium and have it turn into -3, and I can't multiply phosphorus, which is a -3, and have it turn into a +2. Okay, so what we're going to do here is we're going to find our least common denominator. So we've got barium, we have phosphorus. Okay, so barium is a +2. Phosphorus is a -3. So if I multiply 2 times 1, that's going to be +2. 2 times 2 is +4. 2 times 3 is +6. Let's do the same thing with -3. 3 times 1 is -3. 3 times 2 is -6. 3 times 3 is -9. Okay, and if you look here, look at that. So this was 1, 2, 3. So we're going to end up multiplying phosphorus by 2, and we're going to want 3 bariums to get to +6. Okay, you could have also just multiplied the two exponents together. However you want to look at it, you just want to have this in the simplest form possible. So our formula will be barium, and again, we want 3 of those. And then phosphorus, we wanted 2 of those to get to 6. Okay, so Ba3P2. And our formula will be barium. Sorry, not formula. I meant name. Barium, and then we have phosphorus. Okay, our name for phosphorus, we're going to actually take off the whole O-R-O-U-S. So this will be barium phosphide. And that's it for today. So hopefully everything went okay. There are a couple of practice problems to work on. Good luck and have fun.